All right, everybody, buckle up because today we're diving deep into something truly mind-bending, time travel.
Oh yeah, time travel, a
We're
classic.
talking about what science fiction has dreamt up and what actual science has to say about it.
Right, so we'll be drawing on some really cool insights from the astronomical minute for this one.
This is heavy stuff, though. I mean, we're talking about potentially changing the past, shaping the future, maybe even messing with forces beyond our comprehension.
Absolutely, there's a lot to unpack here.
So get ready to explore some seriously mind-bending concepts with us,
Uh-huh.
because we're about to take a trip through time.
All right, let's go.
I guess the first stop on our journey has to be with, well, the man who really turned our understanding of time upside down.
You're talking about Einstein, right?
Exactly. I mean, before Einstein came along, most people probably thought of time as this kind of rigid, unchanging thing. Tick tock, always moving forward at the same pace.
Like a clock, yeah.
Yeah, but Einstein, and especially his theory of relativity, showed us that time is anything but rigid.
Right, he completely revolutionized our understanding of time.
Yeah.
His theories show that time is actually fluid. It can be stretched and compressed.
Whoa, okay, so how does that even work? Like, how can time not be constant?
It all boils down to the relationship between time, gravity, and motion. So basically, the stronger the gravitational field you're in, or the faster you're moving, the slower time passes for you.
Like, seriously?
Seriously, compared to someone in a weaker gravitational field or moving at a slower speed.
So you're telling me that astronauts on the International Space Station are actually aging slower than us down here on Earth, just because they're moving faster?
Exactly. It's called time dilation.
Time dilation. Okay, I'm trying to wrap my head around this. It's a tiny difference, right?
It is a tiny difference, yeah, for the astronauts. But it's measurable. And that's what's mind-blowing. That tiny difference reveals this profound truth about time. It's not constant, it's relative.
That is seriously mind-blowing. And it makes me wonder, if we could somehow control gravity or speed on a massive scale, could we create really noticeable time differences?
Well, theoretically, yeah. If we could manipulate those forces in a big way, who knows? We might be able to warp time enough to create noticeable differences, maybe even travel through it.
That's where the science fiction part comes in, right?
Right. And speaking of science fiction, what about wormholes?
Wormholes, yeah. Those theoretical tunnels through space-time, connecting different points in time or even different universes.
Wormholes are a popular idea for time travel in science fiction. And theoretically, according to Einstein's theory of general relativity, they could exist. But there are some really big ifs involved.
Like, could we even create one?
Yeah, like creating a stable wormhole, and then one that's big enough for humans to actually travel through.
Those are some pretty big hurdles.
Pretty big is an understatement. I mean, we're talking about harnessing an amount of energy comparable to the output of millions of suns.
Millions.
Seriously.
Seriously. So, wormholes might be theoretically possible, but we're nowhere near the level of technology needed to even think about making them a reality. Okay, so wormholes are probably a long way off. But what about black holes? I mean, those things are warping space-time with their insane gravity. They have to be messing with time.
Oh, absolutely. Black holes are basically cosmic laboratories for extreme physics. I mean, their gravity is so strong it actually slows down time significantly.
Significantly.
Imagine this. If you could watch someone falling into a black hole, they'd appear to slow down, like really slow down.
Because of the intense gravity.
Yeah, and as they get closer to the event horizon, that point of no return,
Right.
they'd appear to just freeze completely.
So a black hole is kind of like a natural time machine in a way.
You could think of it like that. And some theories even suggest that certain black holes, the ones that are spinning really fast, might create something called closed time-like curves.
Closed time-like curves. Okay, what in the world are those?
Imagine time as a loop, not a straight line. If you traveled along that loop, you could theoretically revisit the past.
Whoa, that's messing with my head. But honestly, even if it were possible, black holes are terrifying. If time travel means getting anywhere near one, no thanks. I'm good.
Yeah, I hear you. They're not exactly the friendliest places in the universe.
Besides the danger, there are some other big questions that come with time travel, right?
Yeah.
Like, what about the paradoxes?
Oh, yeah, the paradoxes. Those are some brain-twisting problems. Like, what happens if you go back in time and change something?
Right. It makes me think of the classic grandfather paradox.
That's the one, yeah. Like, what if you went back in time and stopped your grandfather from meeting your grandmother?
And theoretically, you'd never be born.
Exactly. It creates a logical impossibility,
Yeah.
which suggests that maybe time travel itself is just logically impossible.
So maybe time travel could literally unravel the fabric of reality.
It's a possibility.
And it's not just big changes like that, right? There's also the butterfly effect. Even making small changes in the past could have huge, unpredictable consequences for the future.
Exactly. I mean, the basic idea is that even the tiniest action, like, I don't know, stepping on a butterfly,
Could snowball into something huge, like a hurricane on the other side of the world.
that's the idea. It really highlights how interconnected everything is and how complex cause and effect can be.
It makes you wonder if we should even be messing with time travel, even if we figure out how to do it. I mean, are we really ready for that kind of power?
Oh man, that brings up a whole other can of worms, the ethics of time travel. I mean, the ability to change history, to prevent terrible things from happening. That's a huge responsibility.
Yeah. It sounds amazing in theory, but think about it. Would we even be who we are today if those past events hadn't happened? And would we really want to risk creating even bigger problems by trying to fix the past?
Right, because preventing one bad thing could unintentionally lead to something even worse. Who knows what the ripple effects might be?
Exactly. And what if the power of time travel fell into the wrong hands?
Oh, yeah, that's a scary thought. Like, imagine governments or individuals manipulating history for their own selfish reasons.
Rewriting history to fit their own agendas. That would be a nightmare.
And what if they controlled access to the technology? The potential for abuse is enormous.
Wow. This whole deep dive has really made me think. Time travel is such a captivating idea, but maybe it's a good thing it's still in the realm of fantasy,
Maybe it's best to leave time alone.
or at least approach it with extreme caution. And we have to ask ourselves, are we ready for the consequences? I'm not sure I am. What do you think?
Well, I think it's a reminder that even as science advances and we push the boundaries of what's possible, we always need to consider the ethical implications.
We can't just focus on can we do it? We have to ask, should we do it?
Exactly. And in the case of time travel, that should we question is a big one, maybe even bigger than the how.
Time travel might be something we dream about, but maybe we're better off focusing on making the most of the time we have right now. The present, you know.
I think that's a great takeaway from all of this.
So what do you think, listener's name? Is time travel a dream worth pursuing?
Mm-hmm.
Or a can of worms that's better left unopened? Let us know.
Thanks for joining us on this wild ride through time. Until next time, keep looking up.
And keep wondering,